All right, so this is part 2 of chapter 33 from the Mahon book, Skin Infections, and we are going to practice. So here is our case study. We have a skin culture that's sent to the lab, collected from a 4-year-old female with an unhealing open sore around her mouth. All right, so first we need to ask ourselves, what plates do we use? We're going to use the blood agar plate, the chocolate, the CNA that's going to grow only gram-positive, the McConkey that's going to grow only gram-negative, and the thiobroth. Now, do we need to set up an anaerobe on that? No, we do not. Okay, so we inoculate our plates. We're going to use the loop to set up the quadrant streak. We're going to incubate overnight, and while we're waiting for that, we can also do a gram stain. All right, so the gram stain results from the swab showed gram-positive cocci. And it looks more like chains, but it's really kind of hard to tell. So all we know for sure is it is gram-positive cocci. Okay, so we're going to look at our plates the next morning, and what do you think we're going to see? All right, we're going to look at first our blood agar plate, and what do we see? So we can see that there are two, it looks to me like if you look far away, it looks like there's two different kind of colonies. You can see that there's one that is beta hemolytic and one that is not hemolytic. Then we can zoom in and look closer, and then here clearly we have some that are non-hemolytic, so gamma hemolytic, and then we have some that look beta hemolytic. All right, what's the next plate we want to look at is our chocolate, and it just looks, nothing exciting, doesn't really look too different from what's growing on the blood agar plate. All right, so there's nothing growing on McConkey, which means that we only have gram-positive organisms in this culture. All right, this is the CNA plate, and again, we have two different looking colonies, so we're pretty sure we have two different gram-positive cocci. And then we're going to look at our thiobroth, and what do we see? Yep, cloudy. So there was definitely growth in the thio. All right, so what do we do? Well, first, in the computer or note card or however we're working this up, you have to notate which colony is which so that if you're off the next day, whoever works behind you knows what tests were done to which colony. So we're going to name number 1 the white gamma hemolytic colony. So I'm going to call this one white, even though I think it's just the light. And then we're going to have the second organism as a white beta hemolytic. Okay, so what are we going to ask ourselves next? Okay, so let's take one organism at a time. So we're going to start with number 1. So the first organism we have the white gamma hemolytic gram-positive cocci. Now, how do we know it's a gram-positive cocci? Did we do a gram stain? Do we have to do a gram stain? No, because it only grew on the blood and the CNA. There was nothing growing on McConkey, so we know we don't need to do a gram stain. So what is the first test that we perform on gram-positive cocci? Period. I hope you said catalase. Yes. So how do we do this? We put a drop of hydrogen peroxide on a slide, we take a loop, we get our one organism, we touch, and we see if there are bubbles produced. And is this a positive or negative catalase? It is positive. So what is the next test that we do on a catalase positive, gram positive cocci? Well, I hope you said coagulase. All right, so we have the patient sample and controls. So we show the patient is negative. So that means it's a coagulase negative staph. But what do we have to do? We have to do a ID and sensitivity. So we're going to make an inoculum of our bacteria. We're going to put it in every one of these 96 well plates. And then we're going to put it into our either microscan walkaway, or we're going to put it in a Vitek card. Now the Vitek is a little different. It has ID cards and then susceptibility cards. So there are biochemical tests in one of these cards, and in the other card is the antibiotics. So pretty much it's the same principle. You make an inoculum, it goes into a machine, it reacts in these little compartments where the reagents are, and then the machine reads it in the end. Okay, so we're going to get an ID and sensitivity on our first organism that is probably some type of coagulase negative staph. So what are we going to do with the second organism? All right, so we know we have a gram-positive cocci, and why do we know we have that? Because it was not growing on MacConkey, and so everything in our culture is gram-positive. Do we need to do a culture? No. I mean, we don't need to do a gram stain. So what's the first test that you do on a gram-positive cocci? Catalase. This time the catalase is negative. So what does that mean? It could be, and it's a beta hemolytic, so we're thinking maybe it's in the strep family, right? So what is the first test that we perform on a beta hemolytic gram-positive cocci that is catalase negative? And let's reflect back on where this skin culture came from. It came from a 4-year-old with open sores around her mouth. So what are we thinking could cause that? That would be a beta hemolytic catalase negative organism. Well, I hope you said group A strep, because that's the most common cause of impetigo. So what test can we do? We can do the bacitracin disc. Okay, so we're going to inoculate a lawn of bacteria on a blood agar plate, inoculate that, let it incubate overnight, and then the next morning we're going to take out our plates with the bacitracin disc, and voila, this is our result. So we have this organism is susceptible to the A disc. There's a ring, so that means that we have definitively group A streptococcus. But what is another option? Because this bacitracin disc, it takes a whole day. What's a test that we can do in just a few minutes? We can do the latex agglutination test for the Landsfield groups. So we would take reagent A, we would take some of our bacteria inoculum. We may have to heat that. You're going to want to follow the manufacturer's instructions. You would do a latex agglutination test, a drop of your reagent, some of your organism, and it is positive for A. So we know we have group A strep. So we know we have the identification, but we don't have the susceptibility. Now, however, strep is one of those, group A strep is one of those that we don't always do sensitivities on, because it's pretty much always susceptible to the same stuff. But what are we going to report out? We're going to report out group A strep contaminated with coagulase negative staph. And what's the diagnosis? It's probably impetigo, but we know that it's caused by a group A strep skin infection. And that is how you would work up a skin culture.